Making your computer faster should just be about adding another CPU, two brains, twice the smartness. Except it's a little more complicated than that. Your modern CPU isn't just one processor, it's already a team. Inside that tiny piece of silicon are multiple cores, each one capable of handling its own task. So technically, by a long stretch, you already have multiple CPUs. But speed isn't just about how many workers you have, it's also about the nature of the work itself. In computer science, we call this Amdahl's law. Imagine for a moment that you're baking a cake. You can hire 10 chefs to decorate it at the same time, but you can't hire 10 chefs to make the cake bake 10 times faster in the oven. The oven is a sequential process. It takes as long as it takes. If your code is the oven, adding more CPUs just means you have 9 chefs standing around watching a cake bake. And it gets even worse. All cores need to communicate with each other because they need to share memory and stay synchronized to avoid stepping on each other's work. And that coordination takes time. So, adding more CPUs doesn't just add power, it adds more traffic and complexity. Then there is something called latency. Even at near light speed, signals inside your computer take time to move. Tiny distances, sure, but at billions of operations per second, those delays matter. At 5 GHz, your CPU ticks 5 billion times per second. That means each tick lasts just 0.2 nanoseconds. In that time, light travels about 6 centimeters. If you put 2 CPUs on the motherboard, they might be 10 centimeters apart. By the time CPU A asks CPU B for data, the party is already over. The clock would have moved on or would need to be delayed. Or in other words, the further data has to travel, the dumber your computer feels. Sometimes your CPU isn't even working. It's waiting for data to arrive from your memory. And that trip, even inside your computer, can take hundreds of clock cycles. So, while your CPU could be doing billions of things per second, it just sits there, idle, because the data isn't there yet. With 2 separate CPUs, you just end up doubling the memory latency problem. Your computer ends up spending more time coordinating than working. But wait, if distance and coordination are such deal breakers, why do giant data centers and servers use motherboards with 2, 4, or even 8 CPUs? To understand that, we are going to use another analogy. Your own computer is like a sports car. You want it to react instantly when you hit the gas. You care about how fast one person gets from A to B. A server, on the other hand, is like a city bus. It's not fast, but it can carry 50 people at once. Servers don't care if one single task takes a few extra nanoseconds to travel across the motherboard. They care about the number of users that can access the network at the same time. When Google or Netflix handles your request, they aren't trying to finish one task faster. They are trying to finish a million tiny tasks at the same time. Serving a website to you and a different one to someone in London and another to someone in Tokyo. Those are independent. So the coordination task doesn't matter as much. So, what does all of this actually look like in real life? Let's take 2 people, a gamer and a creator. The gamer launches Cyberpunk 2077, massive world, crowds moving, physics updating, AI making decisions. A lot of what's happening depends on what just happened. The game can't decide where a bullet hits unless the physics engine decides where the player moved. It's a chain of events that can't be skipped. So even with multiple cores, a huge part of the workload lines up in a single file. And that means that the speed of one core matters greatly. That's why gamers obsess over single core performance. Now switch scenes. Say a creator opens Blender and hits render on a project. Suddenly everything changes. That image can be split into thousands of tiny pieces. Each pixel can be calculated independently. This is a server type of work. With far fewer bottlenecks, every core gets to work at the same time. In this case, because the problem can be divided, more CPUs can actually help. Nonetheless, better scheduling between existing cores often beats having an extra core, not to talk of a separate CPU. So, unless you are planning on hosting the next version of YouTube from your bedroom, one smart chip will always beat 2 talkative ones. With that in mind, appreciate your CPU, like this video, subscribe, and stay positive out there.